class. Welcome back. We're in Module 4 now. This class is entitled Malted Barley and Adjuncts, but ignore the adjuncts part because we're really just going to focus on malted barley today. So to begin, what is barley? For our purposes, let's just start with barley is a member of the grass family. In the beer world, we're really only concerned with two types. We've got our 2-row and our 6-row. So for craft beer, we're really only going to focus on our 2-row barley. It has a lower enzyme content, it has less protein, more starch, and a thinner husk. For what we do, that's exactly what we want. You can use 6-row barley. You're mostly going to see that when the macro breweries, when they create their light American lagers, that's a huge base malt for them. So barley contains all the starches necessary to produce the beer we want to make. However, we have to make it more accessible to us, and the way we're going to do that is through malting. So malting, as you can see in the slides, I go through it in way more detail, but let's just fly through it quickly. It's a 3-step process. It starts with steeping. So you're going to pick your barley and you're going to soak it in water until it gains about 50% of its weight, and then it starts to grow a chit on the end. That little chit means that germination has started, so we're going to drain our grain and move it to a germination room where it will continue to grow until that chit is about the length of the grain itself. At that point, we're going to stop it by moving it to the kiln, where we're going to dry it at a low to medium-low temperature until it reaches about 4% moisture. And that is the entire process of malting in a nutshell. Definitely take a look at the slide in which we cover what that chit looks like, how long you want it to be. It's a really informative slide. So why are we so concerned with that germination process during malting? Well, as it turns out, that the process that creates germination is also what our yeast are going to need on the other end. So all those nutrients that become available to that little growing chit, our yeast need that too. So that's why we're really worried about that germination. We want to make sure that germination is perfect before we stop it and start the kilning process. The whole process of that germination is called modification. So when we talk about our well-modified or fully modified malts, we want those malts that have had a good, strong germination process. The other term that goes hand in hand with fully or well-modified malt is diastatic power. And all that means is it's describing the amount of enzymatic starch conversion potential in any given malt. The more modified the malt, the higher the diastatic power. And where that really comes into play is in your base malts. So as you can see over here, our biggest pile in the whole room, those are all of our base malts because every single one of our beers is going to contain a lot of that. That is because our base malts have enough diastatic power to convert themselves. We can produce an entire beer with just base malt. We cannot produce an entire beer with just black malt. It doesn't have enough diastatic power. It hasn't been fully modified enough. So, when we talk about our base malts, they're generally lighter in color, anywhere between 1 and 10 Lovibond. I'll stop myself there. Lovibond is the scale used to, put beer malts on a gradient, so you know approximately what color they are. Generally speaking, your lighter malts are going to have a lower Lovibond. Your higher malts, because the scale goes up to 500 or 550, are going to be super dark or even black. So, our lighter malts are the base malts. We have our Pilsner malts, our Pale Ale, Mild Ale, Vienna, and Munich. Those are all good, strong base malts for just about any beer. Beyond our base malts, we have our caramel crystal malts. These are malts that have been germinated, but they haven't been killed, they've been roasted. What this does is it converts those starches into sugars, which then can caramelize. What this does for us, let me see if I can hold this up for you. This is Caramel Crystal 60, and as you can see in this, it's a little bit darker, a little bit fuller color, a little bit more golden, and not only that, if you could taste it, it gives you a little bit of a sweeter flavor. It'll give you some caramel flavor in the finished beer. Caramels go all the way up to 120, so all that indicates is that it's a darker caramelization. Beyond that, we have our dry roasted malts. In this case, we have roasted barley on one side. It's going to be hard to tell the difference. Roasted barley, and we have black malt. And those are just different roasts in different colors that just give a little bit darker flavor, roastier flavor to the beers, and obviously create a darker beer. You don't need nearly as much of that in your beer to give it a good, full, dark color. Beyond that, We have some of our adjuncts, and just for the sake of this class, we're going to fly through these. We can have corn, we can have oats. We do have some malted wheat in here because wheat can be malted or unmalted. So there's a whole bunch of different options when it comes to your malts, and all of them come together to create your beer.